What is Newton's first law? So Newton's first law is called law of inertia. What is inertia?
The tendency of an object to resist the change in motion.
That's what it is. The tendency, the inherent property. Does everybody understand the word inherent? What does the word inherent mean? Cannot be changed. It is something that we have. My eyes are brown. I can't change that unless I get surgery or something, right? Which would be weird. I don't know if you can get surgery.
Okay, with contacts.
No, that's not an inherent property. You cannot change your inherent properties. Okay, this is going to sound strange, but there, 2 years ago, a couple of years ago, there was a lawsuit in China where a husband sued his wife because his child was ugly.
Oh, okay.
And his lawsuit said that I married this woman because of how beautiful she was, and I am pretty good looking. Why is my child ugly? What he found was that she had done a bunch of plastic surgeries, cosmetic surgeries to make herself appear to be much prettier than what she inherently was, but she couldn't pass that gene on to the child. Does that make sense? So this is a true story.
Did he win? Like,
I don't know. I stopped following after I was like, oops, this is stupid. And I stopped watching. So in matter, the inherent property is that it doesn't. So what is the one thing I always say? The universe is inherently lazy, right? We do not want to move if we do not have to. How many of us are willing to get up at 5 a.m. to go exercise? People will not get up and do stuff if you are not forced to do so. We are all inherently resistive to motion. When we're moving, we're resisting motion, slowing down, right? Stopping a car when you're going 55 miles an hour immediately takes a lot of brake, takes a lot of effort. Same thing, starting the car up takes a lot of effort. The bigger the car, the more effort it takes. Good. So that is called the law of inertia. We do not want to change what we are doing. Law number 2. Why do I call this the second law? The reason why I call this the second law instead of F equals ma is because F equals ma only exists in situations when mass is not changing. If you write it out, what does it become? Mass times velocity. It only exists as F equals ma when m is a constant. Then you can write sigma F equals ma. If mass is changing, as is the case for most cars and planes and anything else, then we cannot write technically sigma F equals ma. What do we write in that case? Sigma F equals m dv over dt plus v dm over dt. Everybody understands that? This becomes ma as we always have seen it, and this becomes m dot. So instead of saying sigma F equals ma, when the mass is changing, you have to account for the fact that the mass is changing. You could also write this as mv dot plus vm dot. That is a complete definition of Newton's second law. Now, why do we ignore the change in mass? Because in general, when we're talking about cars or planes or anything like that, the change in mass is so small as compared to the other things, we tend to ignore it. We cannot ignore it when we're talking about space shuttles or rockets or where there's a large change of mass. Everybody okay? Okay, what is the third law? But there is one thing we generally forget to add. There is an equal and opposite reaction, but the action and reaction have to occur in two separate objects. Okay, so they do not cancel each other out. And this should be, one should be a, which tells you the direction. So for example, if you push on your friend, so you push on somebody else and somebody else pushes on you. You push this way, she pushes that way. It's an equal and opposite force, but acting on two separate objects. It cannot act on one object. Got it? Okay, now be very careful about this. Now, another thing that I want to mention is the fact that Newton's laws only hold in inertial frames. A non-accelerated frame is called an inertial frame. Okay, Newton's laws only hold for inertial frames. Okay, now here's a question. We're all on planet Earth. Is Earth an inertial frame?
No.
So if I put something here, what will happen to that something? So to me, this is an inertial frame. That has led us to relativity. Nope, we're not going there. But the fact that we are on planet Earth and looking at this little guy hanging from, well, actually two little guys, hanging from my bag, they will not move until I move them. They'll stay there, right? To me, Earth is an inertial frame. It is also called the Earth's rest frame. And there's also a bunch of like fancy words that we use. However, if there was an alien looking down from Mars, Martians looking down, what will they observe this thing doing? Moving as I move. Well, as the Earth moves. Right? Well, yeah. But imagine they could see it moving. And by what speed will they see it moving? The rotation of the Earth and the revolution of the Earth. Both things together, right? So they do not only observe it accelerating because of the rotation, but they also observe it accelerating because of the revolution of the Earth. It's going to be tiny, right? But it is not zero.
Revolution of the solar system.
Yes, and then the revolution of the solar system about the Milky Way, then the Milky Way itself moving around in the universe. Yes, all of those things. Yes. So that we do not have a perfect inertial frame ever. But just like when we ignore the change in mass because it's so tiny as compared to what we are measuring, we tend to ignore that fact. Make sense? Okay, so we on Earth are in a perfectly inertial frame. We are going to ignore everything beyond that.
Kind of like our solar system seems like we're all just revolving, but the whole thing is like moving through space.
Exactly. Oh yeah, and then the fact that the solar system, the Milky Way itself is moving through the universe. Yep. So again, it depends on if you are looking down at something or if you're in the thing itself, right? So for the longest period of time, we used to think that we were the center of the universe, right? Because that was what we were observing. But then we went out and we looked down. We were like, nope, we're definitely not the center. Oh, then the sun must be the center of the universe. Nope, not quite. And then as our vision has improved over time, our frame of reference has changed. It's weird to think about, but this is the beginning of the frames of reference argument.